Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Hello. Let me open up or close my spyware. Here we go. Okay. All right, this is lesson 6, dilations as transformations of the plane. So our first classwork exercise, 1 through 6, it says to find the center and the angle of rotation that takes segment AB to A prime B prime. And then they want us to find where P prime would end up with that same angle rotation. Okay, so to find the center of rotation, we need a ruler. So you take your ruler and draw a line segment that connects the image to the pre-image. So I'm going to draw a segment that connects A to A prime. So I'll use red. And here we go. So draw a segment from A to A primes. There's the first thing we do. Then we're going to bring our ruler up to B and line it up with B prime. Like so. One moment. And draw a segment B prime. So there we go. There is our segment A prime, and B prime. Now we're going to do perpendicular bisectors of both. Let me change to green, and I need a compass to do that. So I bring my compass down to A prime, or A, doesn't matter. I'll put it at A prime. Rotate it, open it more than halfway. Hopefully you remember how to do a perpendicular bisector. And draw 2 circles, and where they intersect is where our perpendicular bisector will go. So I'm going to line up these segments, and I don't know how far out I need to go, so I'm going to go really far, like so. Okay, so there's my perpendicular bisector to A prime. Now I'm going to do the same for B prime. So I bring my compass over to B prime, or B, it doesn't matter which one you do first. Open your compass more than halfway and draw a circle. Bring your stylus over to B and do the same. Okay. Then bring our compass over. Once you do a few of these, they get so routine and easy. Okay, and now I'm going to draw, and I want them to intersect. So boom, they intersected right here. I'm going to put a dot. That is our point of rotation. Okay, so now I've got this really messy drawing. Unfortunately, you doing it on paper, it wouldn't be wise for you to erase everything, but I'm going to erase all my constructions now because I don't need them anymore. I do need the background though. All right, so I'm erasing everything that I just did, except for my point of rotation, and let's call that O, I guess. Okay, so now A to A prime, well, how far is that? So now I'm going to draw a line segment. That's why I got rid of all those lines. It gets really messy if you don't, but unfortunately, on paper, it's difficult to do. I'm going to draw a segment from O to A and a segment from O to A prime. And the angle it creates is our angle of rotation. So whatever degree this angle is, that's how much we're rotating. So A went to A prime, which is a counterclockwise rotation, which is a positive rotation of degrees. So now I'm going to get my protractor. And I bring it down and I put it at O. I rotate it so my 0 line is on OA. And then I look and it is just shy of 60 degrees. So if this line segment extended out, it looks like it's going to be 58 degrees. So I'm going to write that. Our angle of rotation, R, equals 58. degrees. So I need to do that with P. So what I'm going to do now is draw a circle about the center O going through P. So I want a circle with radius OP. And let's make this purple now. Rotate this around and bring it in so that it's going through P. Right here, and draw a circle. So there is my circle, radius OP. And now I need to find the angle of measure from OP over here somewhere, a distance of 58 degrees, if you will, an angle of 58 degrees. So if I bring my compass, or my protractor, I mean, over to 0, rotate it so that P is on that line, make sure my protractor is right at O. My crosshairs have to be right on O, and this 0 line is going through P. 58 degrees is right here, right there. So if I move this now and bring my ruler over and rotate it through that point, so I have a line segment going from O through my point of rotation, which is 58 degrees, and I find on the circle where that dot would end up, which is right there. So there is P prime. So now if I erase my constructions, get rid of everything I constructed, the circle, the segments. Okay, I now know that this is a rotation of 58 degrees, and I know where P prime would be under a 58 degree rotation. First, we had to find the center of rotation and then the angle of rotation. Okay, so there it is. Okay, page 2 brings us to exercise 2. Finally, they're getting into coordinate plane, Cartesian coordinate plane stuff, because these are the types of questions you're going to see on standardized tests. You know, maybe the ASVAB, SAT, PSAT, those kinds of tests. So in the diagram below, we have triangle B prime, C prime, D prime in the 4th quadrant. It's the image of triangle BCD, which is also in the 4th quadrant. After a rotation about a point A, what are the coordinates of A, and what is the degree measure of the rotation? Okay, so we're doing the same thing we did on the prior page. So I'm going to get my ruler. Okay, and I'm going to draw a segment from B to B prime. Okay, and let's see, red's fine. Draw a segment from B to B prime. Move this out of the way. Get my compass. Put it on B. Open it more than halfway. And I'm just going to do little marks this time so I don't have to erase them. So as you can see, halfway somewhere around here, just go perpendicular. Just make sure you make your arc long enough and in the right location. You can kind of get a feel as to where that's going to be. So there's one end, and then I go to B, like so, and rotate it, and then I just want it to intersect. So I only have to do a tiny little mark like that, and then rotate it over to here and do a tiny little mark there. So full circles are not necessary. So then I'm going to draw my line of rotate, or my perpendicular bisector going through these two intersection points. And I'll do this with a dash line just to make sure I can see what the differences are. So I might have to extend that. So let me make it longer. Okay. So there is my perpendicular bisector to B prime. You only need to do 2 because all 3 will intersect at the same location. So I'm only going to do 1 more now. I will do C prime, or I could do D prime. Let's do D prime. C prime looks a little long and might go off the paper and it makes it harder. So I'm going to do D prime. First thing I do is draw a segment from D to D prime. I'll use blue for this one. So D to D prime. There's my segment. And I bring my compass over and put it on D. Rotate it. So I'm not quite on D now, right there. Rotate it and open it so that it's more than halfway. And then you can kind of picture where it's going to be. So you just do a bit of an arc over here. And then rotate it around the other side and do an arc over there. Bring it to D prime. And now make small arcs that will intersect your first arc, like so, and like so. Okay, so there's the 2 arcs that I've created, and now I find where they intersect. So I see it's going to be up here. So I'm going to move my compass, or my ruler, I mean, over like so. Let me put 0 on this end so it rotates properly. Right there. And I will do a dash line. And I will draw it until I intersect. And they cross, they intersect at the point right here, which is 4, 1. Okay, so it says, what are the coordinates of A? Well, that's going to be our point of rotation A, and the coordinates 4, 1. And what is the degree measure of the rotation? So now all I have to do is get my protractor, and all I need to do is put my protractor crosshairs on my point of rotation, rotate it around so that I'm choosing B or B prime. It doesn't matter. I'll put it on B prime. So we're at 0 right here. And then if I get my, where is it? Probably off the paper. There. Let me switch to this because it keeps drawing. All right. So as you can see, AB is my angle of rotation. Do not want to move that. AB is my angle of rotation. I do want to move it a little right there. So, and rotate it so it's right on B right there. And I bring this over to see where the other end is, and it looks like it's a 60-degree rotation. Okay, so point A, 4, 1, and a 60-degree rotation. Number 3 says to find the line of reflection. For the reflection that takes point A to A prime, find the image P prime under that reflection. Okay, so this is not a rotation, it is a reflection. So I take my ruler and I connect A to A prime, like so. There's my A to A prime, went a little too far there. Okay, there's A to A prime. A line of reflection is the perpendicular bisector between 2 points. So I get my compass. Where'd it go? Right here. Bring that down. And let's change the color to blue. And I put my compass on A. Okay, this just gets very routine after a while. Am I open more than halfway but not all the way? Yes, that's fine. Move this out of the way. And I create an arc here, rotate up, create an arc here, move over to A prime, Okay, create an arc here and bring it down to the other arc and create an arc there. And there is my line of reflection going through these 2 points here. There is my perpendicular bisector of AA prime, and that is the midpoint of AA prime. So that is my line of reflection. Now it says to find the image P prime under this reflection. Okay, so all I need to do there is draw a parallel line to AA prime and measure over to my line of reflection. Let me switch it to metric. And that is 10, 11, 12, 13 millimeters. So 13 millimeters plus 13 millimeters is 26 millimeters, and that is right here. So there is my P prime. So let me make it red like the P is. There's P prime. And we are done. Page 3 brings us to exercise 4. Quinn tells you that the vertices of the image of quadrilateral CDEF below, reflected over the line, representing the equation y equals -3/2 x plus 2, are the following: C prime, -2, 3, D prime, 0, 0, E prime, -3, 3, and F prime, -3, 0. Do you agree or disagree with Quinn? Explain. Okay, so keep in mind that in order for us to do this, since this line has a slope of -3/2 and it's going through over 0 up to 0, 2, the point 0, 2, and not the origin, we can't just simply count over, because we don't know how far it is from here to this line. We don't know where the perpendicular is. So we can't just assume that. So what we need to do is, let's see, draw a perpendicular bisector, or draw a perpendicular line that goes through our line here and our 4 points so that we know how far each one is away. Okay, so how can we do this? All right, so let's look back at Algebra 1. And if you have a line with a -3/2 slope, then you should remember, and hope, well, maybe you don't, but you need to remember that in order for a line to be perpendicular, the slopes are negative reciprocals. So I need an equation, y equals 2/3, positive 2/3, the reciprocal of 3/2, and the positive, or the negative reciprocal, in other words. So y equals 2/3 x, and then depending on where the line goes through. So if I pick a point such as F, which is at 0, 5, a 2/3 slope means to go rise to right 3, or down to left 3, which is here. Didn't have my pen. Try that again. So from here, go down 1, 2, left 3 would put me right here. So this is F prime, and that is the point -3, 3. And if I go up here, F prime is -3, 3. That's okay. We're good there. Now let's check the next one. If I start at C, then I need to go down 2, left 3, and that puts me here. So this is C prime, and that is the point -3, 2. So go up here, C prime is not -3, 2. So that is incorrect, but I will continue. D is at 2, 1. I need to go down 2, left 3, down 2, left 1, 2, 3, and that would put me here at the point D prime, which is the ordered pair -1, -1. And D prime is at the origin 0, 0. So that's obviously not in the right location. And then finally E. Let's switch to purple. E is at 4, 4. And I need to go down 2, left 3. So I go down 1, 2, and over 1, 2, 3. Not far enough. I'm not on the opposite side of the line yet. So I have to do it again. Down 2, over 1, 2, 3. And that doesn't look right either. So go down 2, over 1, 2, 3 a third time. Would put me here. Okay. And in essence, what I have done is drawn the perpendicular bisectors using the grid. So let me show you that. So if I connected D prime to D, it is right there. Okay, and that is too far away. So that is not correct either, because I need to only be this distance away, and this is way further. So I need to move this point now closer. Let me move the point first. All right, let me erase this because that's not correct. So where does D prime go? Let me erase that. So this was down 2, over 1, 2, 3, which puts me here. And that's the slope of our line that it has to be on. That's all that tells us. Then we need to know the distance from here to here and find the distance from there to there. Okay. Now I'm going to move this line to E and extend it over to here. And it went 1, 2 and a half and over 1, 2, 3 and 3/4. So go down 1, 2 and a half and go over 1, 2, 3 and 3/4. This point that I put here needs to get moved closer. So I'd have to measure from here to here and then measure from here to here. The only other way I could do it without measuring would be the Pythagorean theorem, but we're not going to do that. So let me rotate this like so. This is probably the best way to do it. Measure, rotate. So from E to this line was 4 and a half. So I need to go 4 and a half more, which is a total of 9. So it would be right here. Okay, so there is E prime. And D prime is, let's check D prime. So that is 1, so that should be over 2. So I need to move that. So from D to this line is a distance of 1 centimeter. So go another centimeter and we would be right here. There's D prime. Now if I move this line to F, that is the correct slope. This point is somewhere on that line. So let me move the point. This point here is going to go somewhere on this line with a slope of 2/3. Okay, just trying to get this accurate. Move this up to here. And if I measure from here to the line, that is 1.567 and a half, roughly 1.8. And 1.8 and 1.8 is 3.6. So then I move this dot to 3.6, which would be here. And it would have to be on this line. It's hard to grab that small point. I should just draw one at 3.6, but you get the idea. And then finally, I will put this at C. That green dot has to be on there somewhere, but we need to be the same distance C is from the line. And that looks like a 1.1 centimeter or 1.2. Let me just rotate this to move C out of the way and then bring it back and remeasure that again. So it looks like about 1.1. So I want 2.2, which is right. Ay caramba. Here, right there. Okay, so there's C prime there. So C prime, F prime is right here. C prime, F prime, E prime, D prime. So what it will look like is this here. My point should be pretty close to this drawing if I scale it properly. Okay, it's close, but it's not exact. All right, but if, as you can see, -2, 3 is C prime. So if I go -2 up 1, 2, 3, it's not quite there. So these values are not correct. This is not at 0, 0, and E prime should be at -3, -3, and it's definitely not. It's -3 point something, -1. Okay, so do I agree with Quinn? And the answer is here. Let me move this out of the way now. So I'd say I disagree because under a reflection, an image point lies along a line through the pre-image point that is perpendicular to the line of reflection. For example, the line representing the equation y equals 2/3 x plus 4 includes C, which was this one up here. So if I move this over to that one, and the reason I chose that is because it's right on the y-axis, so you know your y-intercept is 4, and the equation would be the same for f. It'd be y equals 2/3 x plus 5, and then these would be fractions for the y-intercept or the constant. Okay, so however, it does not include the point -2, 3. It's off. Similar reasoning can be used to show that Quinn's coordinates for D prime, E prime, and F prime are not the images of D, E, and F respectively under a reflection over y equals -3 halves x plus 2. Okay, number 5 says a translation takes A to A prime. There it is right there, a translation. Find the image P prime and the pre-image P double prime of point P under this translation. Find a vector that describes the translation. So remember, we have to draw vectors. So in order to do this on paper, if you were to do this on paper, you would take your ruler and you would put your 0 at A, measure to A prime. It's just a smidgen over 5 centimeters. Yours would probably be different on paper. So you would need to create a vector of that length. So I will choose vector, I'll choose this, and I will choose red. No, I'll choose blue because the dot is red. All right, so I'm going to draw a vector from A vector, hello. Thought I already did all this, from A to A prime. So then what you would do is take your ruler on paper and move it up to P, like so, and measure over to P prime. So that in essence would do what I can do electronically, you can't do on paper, but what it would do is move this. What are we doing here? Move this, hello, to there. So I'd put a dot right here and call that P prime. Repeat the process again to get P double prime. So you just move your ruler over and draw another ray from P out to 5, like so, and move your ruler, put a dot at the end of the ray, and call it P double prime. Okay, so a translation takes A to A prime, found the image P prime, which is the same distance and direction from P that A prime is from A, and pre-image P double prime, and find a vector that describes this translation. So the vector is a vector of length 5 centimeters going to the right. Okay, what are we on? Page 4, problem 6 is now on the coordinate plane. Point C prime is right here at -2, 5. Point C prime is the image of point C under a translation of the plane along a vector. Okay. Find the coordinate of C if the vector used for the translation is B to A. So be careful of your direction. B is our initial starting point and A is our end point or our terminal end with the arrow. So I would need to get a ruler if you're on paper, and I do that all the time. Bring this down, rotate it, so we have a nice straight line going from A to B, like so. I'm going to use my ray tool simply because I don't have to use the ruler. I'm just showing you that this is what you would do on paper. You would draw a segment from B to A, like so, and put the arrow at the A end. That tells us that A is the image of the pre-image B. So I move B down 1 and over 1, 2, 3. So now that I know that direction and distance, then I take my ruler up to C and draw a segment of the same length. So if I were to measure that, actually we can use the grid here because we just went down 1 over 3. So if I put my ruler here and count down 1 over 1, 2, 3, we end up at this point here, -5, 4. So I'd put a dot there at -5, 4, right there. Move my ruler, or actually you'd use your ruler to draw a ray. I'll just use my ray tool. And I will draw ray C prime this direction, because it has to be the same direction as the initial BA. So that would put my C right here, because it said if the vector used for the translation is B to A, C would end up right here at the point -5, 4. Now part B says, so that would be the point, like I said, -5, 4. All right. Now it says find the coordinate of C if the vector used for the translation is A to B. So now all we're doing is rotating this vector around. I will just do it this way because you just use a ruler. And now we're going from A to B. So vectors tell us direction and distance. So this is telling us to move in a direction to the right and up, a distance of 3 to the right, 1 up. Okay, I could find that distance. This is length 3, this is length 1. Pythagorean theorem will give me this side. So 3 squared is 9, 1 squared is 1. So this is a length of the square root of 10. Okay. And then it says, find the coordinates of C if the vector used for the translation is A to B. Okay. So if I do that, I would put my C prime here at C prime. And that would move it to this 0.16. Okay, so I would put a dot right here. Okay, so that is the 0.16. Right here. 1,6. Now let me think about this for 1 second. This would be C, and this would be C prime. Find the coordinate of C if the vector used for the translation is B to A. Okay, I'm okay with that. Okay, so in thinking about this, these might be, if you think of it a different way, the answers may be this way instead. And let me explain. Okay, so if we used the vector BA, find the coordinate of C, the vector used for the translation is BA. The point C prime is the image of point C. So C is the pre-image. So we should be starting here. So that is right. I just had to think about that a little bit more. So I'm going to move this, and I want to put this vector here. This should be C. All right, so C is the 0.16 with the vector from B to A is this direction. All right, so the other one would be the vector from A to B would go this way, and C would have to have been back at -5,4 to get to C prime this way. All right, that's the way of thinking about it. So there are two vertices. I just had them backwards. Okay, this is page 5, exercise 7 and 8. All right, page 5, exercise 7. A dilation with center 0 and a scale factor of R takes A to A prime and B to B prime. Find the center 0 and estimate the scale factor. All right, so this is a dilation. So the easiest way to do this is to just get a ruler, not a compass, a ruler. And I'm going to draw a segment that connects A prime to A. And I'm going to continue it in that direction well beyond. And it's going to look like this. So O is somewhere on this line because we took A away from O on that ray, if you will, to A prime. We're now going to do the same with B prime. And I'm going to put my ruler on B, rotate it to B prime, like so, and then line it up, and then where that intersects is going to be where right there. Okay, so I'm going to draw a line segment now through here, and where those two just intersected is where my point O is going to be. So here is the point O of reflection. So the center O is right here, and we need to estimate the scale factor. So all I need to do now is put my ruler on OB and measure OB. So over here, I'll say length of OB equals, and it's 3.567, 3.7 centimeters. And then I measure out to OB prime. And the length of OB prime is 7.4 centimeters. Now, B prime is beyond B, So this is a scale up where r is greater than 1. So I make this a fraction, but in order for a fraction to be greater than 1, the numerator has to be bigger than the denominator. So I'm going to say OB prime over OB is going to be our r. And that equals 7.4 over 3.7. And that's going to equal, get my calculator, 7.4 divide by 3.7. Enter, and I get 2. And that is our r. Okay. All right, number 8 says given a center O. O is given. My pen's upside down. O is right there. Scale factor of r equals 3. And a point A and B. It says find the point A prime, which is a dilation about O of a scale factor r of A being 3 times as long, and B the same thing. Compare length AB with length A prime B prime by division. In other words, find A prime B prime divided by AB. How does the number compare to R? So the first thing I'm going to do is draw a segment from O through A. Okay, so red, that's fine. And I just draw a segment through OA. Rotate. Hello, I clicked on the edge. That's supposed to be rotate. Rotate it so that it's lined up like so. A little bit, there we go. And same thing. Draw a segment through from O through B. All right, so there's our 2 rays. So then I do this and that. All right. So it says R equals 3. So if I put this back and measure, OB equals 3.75. So if I multiply that by 3, I need 11.25. So here's 11 and 2.5. Halfway between 2 and 3 would put me right here. Move this. Here is my B prime. Rotate. Bring my ruler up to 0 at O. Rotate it. A looks like 2.55. So OA equals 2.55. R is 3, so that means to multiply by 3. Carry the 1. Carry the 1. 7.65 is where A prime should be. Here's 7.5, here's 7.6. Halfway between 7.6 and 7.7 is about right there. Move my ruler. This here is A prime. It says now to draw AB prime, A prime, B prime. So I rotate my ruler and I will put that at 0. So here is segment A prime, B prime. The length of it is 7.25. So A prime, B prime equals 7.25 cm. I come down here, I draw segment AB, and AB equals That looks like 2.4 roughly. So if I take 2.4 and multiply it by 3, 4 times 3 is 12. 3 times 2 is 6 plus 1 is 7. Well, there's 7.2. That's 7.2 or 7.25. So those two are very close. So A prime, B prime is 3 times as long as AB. So they do compare to our scale factor, R equals 3. Okay, page 6 brings us to number 9. Given a center O right here, scale factor R equals 3, point A, B, and C that form an angle of 60 degrees. Find the point A prime that is a dilation about O of R equals 3 of A. B prime is the same dilation from O, and C prime as well. Okay, it says to compare the measure of angle ABC with the measure of angle A prime, B prime, C prime. So what we're going to do is get our ruler, put it on O. This gets pretty routine after a while, doesn't it? And I guess that's why we do so many of these. We get good at it as it gets easier. We're learning the concept. That's the goal. So there's my ray OA. I didn't want to move my ruler. I wanted to rotate it. The next one I'm going to do is ray OB. And then finally, ray OC. Like so. So that's what your paper should look like for now. I put arrows at the end here because they're rays. Okay, so we have an R equals 3. So what I want to do is put my ruler back here. And since it's already lined up with C, I just like writing the lengths down over on the side. So I'll do it right here. OC equals OC prime equals OA equals OA prime equals, and OB equals OB prime equals. So I just want to find all these segment lengths. So OC is 4.7 centimeters. And since I don't want to move my ruler, I'll just leave it there. I want to take 4.7 times 3, and just to save time, I'll do this. 4.7 times 3, enter, is 14.1 centimeters. So I go out to 14.1, it is right here, and I put a dot. Rotate up, and after I move my ruler, I can label that C prime. A is 2.7. OA is 2.7 centimeters. So 2.7 times 3 2.7 times 3 equals 8.1. So OA prime is 8.1 centimeters. 8.1 centimeters is right here, and that's A prime. Rotate this now down to B. OB is, well, now that I've rotated, I'm off a little. Let me just move this right there. OB looks like between 3.9 and 4. Let's call it 3.9. OB is 3.9 cm. 3.9 times 3 is 11.7. So I move out here to 11.567 cm, and it is right there, right here, and that is B prime. Now I want to create the angle A prime, B prime, C prime. So B is my vertex. And so I put my 0 on B, like so. Rotate it, so I'm going to C. Let's change it to green. And I'm drawing my angle over here. And then I rotate, and I want to draw a segment from B prime to A prime. Okay, went over just a smidgen here. Okay, so there we have it. There is my angle A prime, B prime, C prime. So A prime, B prime should be 3 times as long as AB. B prime, C prime should be 3 times as long as BC. And what do we know about the angle measure of the new angle? So it says, compare the angles. What do you find? So if I put my protractor crosshairs right on the vertex and then rotate so that I'm right on that line segment, BC, or the ray BC, B prime, C prime, and I move this over right onto A, then that looks like about 62 degrees. All right. This says 60, but if I move my compass over, or my protractor over here, okay, it is off just a little bit, but it's pretty close. So this is just a slight error of where the ruler was. Just a slight little change can throw it off depending on how far out you're going. So that's pretty close. It should be 60 degrees as well. Page 7 brings us to the end of lesson 6. Review your lesson summary and go to your problem set.